Hello everyone. So in this tutorial video, I will show you how you can set up a RAID1 configuration inside a single LUKS container, which means you only need to give your password once. So in case you don't know what these terminologies are, so LUKS stands for Linux Unified Key Setup. So it allows you to create an encrypted container. So think about it like this, if you have a hard disk drive or you have a pen drive, you can encrypt it, which I highly recommend that you do, so that in case you buy a new hard disk and the hard disk fails, you can send it for repair. So you are not sending your data which you cannot delete. It happened to me once that I bought a new hard disk. I put some data into the hard disk, but it was not encrypted and it failed. So I was no longer able to delete any data from it, but I was still able to read some data. So I had to send that drive for repair. Fortunately, none of those videos were very important which I had put in the drive. So it is highly recommended that you should always encrypt your disks. Second thing that we are going to do is we are going to be doing this using the BTRFS file system. And the BTRFS file system has several advantages. For example, metadata mirroring. The files are self-healing. It gives very fast snapshots capabilities. Now, if you don't know about all this, maybe I can make a video on all these later, but I will give a link to these articles in the description which you can read. So you can see that it has efficient drive storage, data consistency of backup, etc. So a lot of good features are there in this file system. And secondly and lastly, actually, what about the RAID? So this is the RAID 0 configuration. RAID 0 configuration simply means you have a drive 1, you have one disk, you have another disk, and you combine them together to make a one big disk. That is called a RAID 0 configuration. So imagine, let's say for example, you have a 1 terabyte hard drive and you have another 1 terabyte hard drive. You combine them together and you will get one 2 terabyte hard drive. So that's how the system will see it. And you can store your files into it, and you can see that all the files are stored like 1, 2, 3, 4, 5, 6, 7, 8. But the problem is, even if one drive will fail, the entire setup can fail. The second, which we are doing, RAID 1, is basically mirroring. So this is good for archival purposes, and the way I use it is, let's say for example, you have a laptop which has 1 terabyte hard drive. You buy a hard disk which has 2 terabyte space. You set up a RAID 1 configuration which is mirror, which means if you have a drive, you split it into two. First part is used as block 1, drive 1. Second part is used as drive 2. And whichever data you copy, let's say you copy block 1 will be mirrored in both the places. So the idea being, even if one of the parts get corrupted, the other one can be used to heal that part. So that is RAID 1 configuration. So that is what we are trying to do. So let me explain. What we are doing is we are creating a container which is encrypted. It's an encrypted container, so you need to give a password to enter the container. Inside the container, there are two drives which are created using the same space. So there is a single disk that we have. Let's say I have a 16 GB pen drive, but you can do it on any space disk, and you split it into two parts, and they will be set up in a RAID 1 configuration. So whenever I copy a file, let's say I copy a file 1, so file 1 will be copied 2 times. So of course the speed of copy will also be slow because you are copying the same thing 2 times. And the advantage that you will get is good archival. In case one part gets corrupted, it can be healed using the other part. But of course the risk is that both parts are on the same drive. So if something happens to the same physical drive, you are in trouble. So this is why it's a good idea to do a cloud backup also. Okay, so let's start. What is the process that we are going to follow? First thing that we are going to do is we are going to check whether we are using the right drive or not. So we are going to check whether we are using the right drive or not. So what I mean by that is, if you see here, issue the command lsblk. and double check you are using the correct drive. In this case, it is SDB, because the reason is you don't want to accidentally format the wrong drive. And double check the size. This is exactly what you want to work with. So this is good to go. Again, double check, triple check. You don't want to accidentally format the wrong drive. Okay, second thing that you want to do is you want to create the LUKS container. So this is the second step that we are doing, and this is the command that we will issue to do it. So you say sudo cryptsetup luksFormat and give the drive name, which is dev sdb, which is this one, and press enter. And now it will ask you for your computer password. So make sure you give your computer password over here. And then it will ask you for confirmation, type yes. Now it will ask you for the password of the encrypted container. Okay. Make sure you give a different password, a strong password, and not the same password as your computer. This is the password that you require to uncrypt or decrypt the drive. Now it is done. Now if you can again issue lsblk. You see right now we only have SDB. Next thing we need to do is we need to open the container that we have just created. So in order to do that, you give this command and also give a name. In my case, I'm using mount name, but you can use whatever name you like. This is the name under which the encrypted container will be mounted. So you give this command and now it's going to ask for the passphrase, not for the laptop, but for the encrypted container to open it. Give that. And again, if you issue lsblk, you will notice that your container has been mounted in mount name. This is the same name that you gave here on top, mount name. Okay, the next step is optional. That's line number 724, which wipes out all the data in the drive, which is, if you are very security conscious, you are doing something mission critical, you can do that. It will take time. In my case, I'm skipping. So next thing that we need to do is we need to create a physical volume. So this is the command that we use to create a physical volume. So let me draw and show you what we have done so far. We have taken our drive. Let's say this was a 16 GB pen drive, but it can be any size. Now we have created a container inside it. This is the LUKS container or the encrypted container. Now inside this encrypted container, we are creating a physical volume. So this is your drive. This is the container, encrypted container. And this is the physical volume that we are creating. So this is the So in order to do that, we issue this command pvcreate and the mount name that we just provided. Now you can do a PV display. And this below one is the physical volume that we have just created. You can see the size 14.98 GB. This is the new one. The upper one is the one which the laptop is already using. You can see the UUID also. Next thing that we need to do is we need to create a volume group. So what that means is after we create our, so this is your physical volume. Inside physical volume, you create a volume group. So this is your physical volume. This is your volume group. And this was your encrypted container. And this is your pen drive, which you are using. So this is the volume group that we have just created. So volume group has been created. Now inside this volume group, we will create two logical volumes. Because in this case, we require both of them to be of equal size. So the first one that we use, we are saying take 50% of the free space in the volume group. So it will take 50% of the free space. The other one can take the remaining 100%. Now, again, the reason why we are using 50% and 100% is, imagine this. You have, let's say, 1 TB. First will take 50% of it. So let's say 500 GB approximately. So the remaining one can take 100% of the remaining 500 GB. This is why we are using 100%. They don't have to be equal, but in this case, I'm making it equal. So now we have created two logical volumes inside of the group. In other words, two logical volumes have been created. 1, 2. Inside this, we will set up our RAID configuration. Now, you can mount it any way you like. In this case, I'm just using disks to mount it. So if you go to disks, you can check in the file explorer also that these are the two volumes that you have. I mean the logical volumes. And now this is where you set up the RAID1 configuration. You copy this command and you give the command. So basically what we are telling here is that we are asking BTRFS to create a RAID1 with a label of laptop backup C. That is the label. You can give any label you like. That is the label. And the directories or the data is going to be in RAID1 configuration. And the metadata is also going to be in RAID1 configuration. We want to force it. And these are the two logical volumes that we want to use. So once you issue this command, your RAID1 configuration will be ready. But now we have some permission issue. You will not be able to create any files inside it. We can try that. Let's mount it. Let's open disk. Now you see here, I have two 8 GB, approximately 8 GB parts. They are in RAID1 configuration. No matter which one I will mount, they will be mounted as a single unit. So I can mount any one I like. Let's say I mount part 2. You will see they will get mounted on laptop backup C only. So you can click to open it. And right now, if you look at the properties of this folder, it belongs to root. So now I need to change that to my user, which can be easily done by issuing this command: sudo change owner, your name, and the path where it is mounted. So once you do that, you should be able to create files inside it. And let's try to copy something. So this is where I have opened that particular RAID1 configuration, and I'm going to copy a file inside it. So now the file is being copied. And notice that the copy speed is usually slower than what you would normally have. The reason being, this same file is being copied 2 times. First copy will rest in the first logical volume. Second copy will be in the second logical volume. So let's fast forward that. So now you see the copy is almost about to get finished and it's done. Now look at the properties. The file is approximately 2 GB in size. And you see here it is telling us that 2 GB is being used. Even though the file was copied 2 times, it's showing 2 GB is being used. Another thing you will see is that it's showing us that, the capacity is 8 GB and it is BTRFS file system. Why 8 GB? Because of the RAID1 configuration, the 16 GB got halved to 8 GB because the data is being mirrored and the file system is BTRFS. Now we can do one more test. I can create a folder called test and I copy the same file inside this. So now I have duplicated this file. I have the 2 GB file 2 times now because BTRFS is write on copy and they are same. So right now actually no copy has taken place. Only the metadata has been duplicated. If you go to properties, still it is showing 2 GB is being used. Although I have duplicated the file, it is still showing that 2 GB is being used. So our RAID1 configuration is working perfectly. This is just a verification. You don't have to do it. This is just for your knowledge. that, if you issue BTRFS file system show, it is showing you that you have RAID1 in 2 disks, approximately 8 GB, out of which this is used. It's not showing double the size. You can cross verify it by giving this command. Again, you don't require it to create RAID1. This is just for your information. You can show the file system disk usage, and you see that total space is 3.74. That is double of what the size of the file was, but out of which approximately 2 GB is being reused. So we can see we had one file on the root, which is this one, another file over here, which we copied, but it is being reused. You can see here, that's 1.87 GB of data. That's the first one. And this one is being reused. And you can check the block ID also. You get a single UUID for the container that you have. And this is where you can see the format of the disk. You can see they are in RAID1 configuration. The data and the metadata and the system are in RAID1 configuration. We can check here. And what is the size of the data? 2 GB, out of which so much is being reused. System is so much, metadata is so much, etc. Now the process of unmounting. How do you unmount this? Because we see we have many layers which are going on. So how do we unmount all of them? So let's see how to do that. First of all, we unmount the container that we have. So that's being unmounted. We can check now. It's no longer there. Another thing that we do is you can see your open volumes. You don't have to see it, but this is just for the knowledge purpose, that we can see that, these are the two logical volumes which are open right now, part 1 and part 2. To close all of them, this is the command that you need to issue. Line number 764 is optional. It's only for academic purposes. Line number 767 is what you have to issue. So you issue this command, and again try lsblk. Now you see here we had part 1 and part 2. Here they are gone. We only have mount name now, which is our LUKS container, and we can unmount it by doing it like this: cryptsetup LUKS close and the name of the container, which is mount name, where we mounted the container. And now you see we are clean.